Thanks for that overly kind introduction. I want to lower your expectations now so that I can surprise you with how hopefully good the talk is rather than raise them high and then knock them down.
He doesn't write enough blog posts, otherwise he's really good.
Yeah, that's true for all of us, right? You always wish you could write more, document what you actually code, that kind of good stuff. So I wrote a post a few months back about two cultures. And you know what I found really interesting about RedMonk is that we look across so many different communities, and a lot of the coolest things you learn are from looking at very diverse places and asking, how can I take something here and apply it over there? Just like this conference, right? We're talking about craft from steam engines to, I think there's stuff I can't talk about tomorrow, but it's going to be weird and different, and I hope you can learn something from it. And so that's what I did here is, I spent a lot of time sort of being a data scientist myself. In science, I was doing drug discovery until a year ago, and then switched gears completely. And you heard a little bit about DevOps from Rafe this morning. And so this is sort of thinking about, all right, these cultures both have some things that are really useful and good about them, but there's also both got some major holes and some ways you could learn. And then James insisted that beer somehow be involved in the talk, so I just added a word to the title. And I had some for lunch, and that's about all there's going to be. So first off, what are these things, right? You're probably familiar with one or the other, but you might not know about both. So I put together dug up a couple of fun Venn diagrams for you, because everybody loves a good Venn diagram. Switched around the Venn diagram somehow, actually. But so data science is basically the intersection of stats and machine learning and computer programming and knowing something about the problem domain, right? So being an expert in the problem space. So this is actually a DevOps Venn diagram, so just completely ignore that one. But instead, go look up Drew Conway, and he posted an awesome post about basically what is data science, because it's this sort of new hot thing, and basically people are wondering, what is it, why should I care, what do I need to know about it? And the interesting thing is that if you don't have all three of those, right, if you don't have the math and stats skills, the programming experience, and the domain expertise, then you're going to run into serious problems one way or the other. So for example, if I'm trying to model the growth of GitHub, and I don't know anything about math, and I just look up a couple things up on Wikipedia and say, oh, well, that's going to be right, without bothering to understand how it works and why it works, you're going to run into issues. And then, yeah, same one again. DevOps is essentially, how can you mix together all these different areas to enable things to get out to production more quickly? All right, and something that, even people who sort of follow what's going on here don't realize that it's not just about coders and ops people, right? It's actually about a business problem. And that's the same thing we've been talking about here with craft, which is understanding the entire business is really valuable, right? So I was talking with Dave Johnson over lunch about, craftsmanship as it pertains to software development. And so you don't want to be a cog in a wheel who's just told what to do and said, here's the architecture, here's the function name, just fill in the blanks. You want to really understand the problem, just like in the military where there's a commander's intent, right? So every soldier knows what the goal of the overall battle is supposed to be. And so, it's probably not go sit on that hill with a gun. It's going to be like, let's take over this fortress or something. And so even if you go there with 1,000 people and 995 are killed, those 5 people don't just sit there on the hill with their guns. They figure they have to get together and think, how do we actually accomplish the initial mission? Right? And it's the same thing with development. You have to think about, why am I actually working on this code? What is it supposed to do? Rather than, I was told to write 500 lines of code today, so I'll just bang those out. You have to put thought into the process too. And here's something about drinks, so you get your data. This is a survey that Zen did, which is the PHP company. And they do a survey every year about software development, but they also ask a weird random question at the end. And this one was, how do you feel about beer? And it turns out that developers really like beer. I know you're all surprised being here. Shocking, right? You like beer. But in fact, they all like beer, well, with a few exceptions, and some of those are addressed by the gluten-free beer. So James talked about how I do data stuff all the time. This is actually just a hand-wavy talk because I'm trying to learn from him and do some of the things his way while he gets some of my data skills through osmosis. So, what could data science learn from DevOps? If you got this culture of these hardcore data analysts, and then you've got another culture that's about, continuous delivery and being very reliable and resilient. And it turns out that, a lot of data scientists don't know anything about programming. They're coming to it from the world of being like a statistician. And so they come to this, they try and do software development, but you all know how long it took you to become productive as a software engineer, not just as a coder, right? Thinking about all the tools involved, using version control, all these kinds of things that they come in and they actually don't know anything about this. They treat it just like old school sysadmins did, right? You just bang out a Perl script or you log into servers individually and do stuff. But that just doesn't scale, right? And we're talking about scaling craft, and DevOps is scaled craft, and data science hasn't successfully done that yet. And I put the picture up just sort of thinking about this is what data science looks like today, and especially the after-party cleanup part of it, where it's a lot of fun while it's happening, but then you go back later on, you're like, what the hell just happened there? This is just a gigantic mess, and I can't believe I have to deal with it the next day. So, the first main point is one of the key tenets of DevOps is basically infrastructure as code, right? So you describe stuff using Puppet or Chef or CF Engine or whatever your favorite tool is, and you describe what a server looks like in code that you can maintain in version control, and that you can very easily scale to multiple nodes. And if you think about how do you apply this to data science, well, what these people are doing today is they'll just start up R and type in some commands, run an analysis by hand, and they won't save it. They won't write it as a script. But so the idea of doing data analysis in a scriptable way that you can put into version control and that you can maintain and collaborate on is something that needs to start happening. And are there any data scientists here, by the way? Anybody who's awesome? So come tell me about how wrong I am afterwards, please. Or actually, go ask him your questions instead of me. So now when you're writing code, you're always testing the code, right? Using something like Jenkins, for example. But once you're dealing with data in addition to the code, you have to start realizing, well, it's actually possible to also apply tests to the data, right? To the way it looks in the beginning, to the way it looks afterwards, to, does it map to the way you think it should look, right? And so you go into this with some preconceived notion of thinking, I was working with this GitHub user growth data, and the first thing I did is I just plotted it to see what it looked like. Does this make sense? And then you can use that to write some tests around, making sure it continues to make sense. Because, good data science is going to be data science that you can replicate and keep doing over time. It's not going to be a one-off analysis. It's going to be, okay, I wrote that as a one-off analysis, but I wrote it using code and I checked it into GitHub so that I can just rerun that script anytime I want. In fact, I could even plug it into my monitoring setup and turn it into a live metric instead of just a script that I have to run by hand once a month or something ridiculous like that. And so you have to think about, first of all, a lot of data scientists aren't testing their code, but second of all, they need to test their data. And this goes, I'm sure a lot of you work with data on a daily basis too. And so you have to think about, how can you write tests to make sure that data looks the way it's supposed to look, to detect weird anomalies that are being added, to, if your transaction rate on your shopping cart suddenly goes up by 10,000%, that's something you want to notice, right? And it's something that if you've ever set up monitoring, a lot of it is based on thresholds today, right? It's not based on being smart about the data and really understanding what the data is doing. And so, by applying data science to the solution would be saying, hey, if this is outside 99% of everything else there, show it to me. I don't want to know what kind of threshold it has to be, because that's where you start getting into the domain expertise, and you can't always be an expert in everything. But if you can instead just say, here's a bunch of stuff, what does it look like, what's normal, what's weird, how can I describe it as a pattern, and which points don't fit the pattern, suddenly you've got something a lot more interesting, and something you can test for anomalies and not just write a test that says, hey, if it's less than 5, let me know. Now, you guys don't need to be told to use version control, but like I was saying, with people who come from a statistics background or a math background, they're not used to doing that kind of thing. And so, it's very important when you're talking to people who come from different backgrounds to think about these things that you take as a given that are just assumptions of how you work every day, and reconsider, put together that mental model of what are all of the assumptions about how I do my job effectively. so that you don't forget about them when you're trying to tell other people how to interact with you. Right? Like imagine you're trying to talk to some business analyst and you're trying to share some data with them and they maintain it in an Excel spreadsheet. Well, how do you do that, right? So you have to teach them, how can you do version control? How can you maybe ship that out of Excel and send it up to GitHub or something else? And do it in some sort of scalable way so that they can keep using the tools they want to use, but at the same time you're able to work in a way that's effective for you and help them work in a way that is effective for both of you. And the other thing that's not happening today in data science is it's a very much an individual endeavor, right? You go lock yourself in a room and then stay there for a few hours and you come out with some amazing insight. Or a few days. And that's, I was a scientist before, and now I may be a data scientist, I'm not really sure. But when I was doing science, that's exactly how it worked, right? You have a collaboration, but that means that you both go off and do your separate things and you come together 6 months later and try and fit together all that crap you did while you weren't talking about it the whole time. So, it's really important to think about how you work together and how you can help other people in different domains work together with you and with themselves more effectively. This is a picture from the Haiti earthquake in 2010. And I was looking for something about a bucket brigade to really tell you what continuous delivery looks like. This is the closest thing I found where they've got a human chain rescuing people out of the building. So it's not humorous, but it is important to think about all the weird ways we can apply the same kinds of ideas, right? Continuous delivery is really just a bucket brigade. And in data science, it's one of these things where people do the work and it's a one-off script and it's not ready to go into production. And so if you want to do things right and do things, the DevOps way, right? Learn about how you can be more reliable, more resilient, how you can deliver things faster. You can just write an analysis as a script. And as a script that is, pushed out production, let's say, like Rafe says, 30, 40 times a day, whatever it is. And another key point is you have to think about when you're creating an analysis or when you're writing code, right? You architect for scalability, but you don't write the code for scalability in the first place, right? One of the founders of computer science, Donald Knuth, said premature optimization is the root of all evil, right? And a lot of people take that as optimization is the root of all evil, which is not actually the case, right? Sometimes you do have to optimize. You can't always write everything in Ruby or Python. There are sometimes things that need to go fast. And it's at the point where you actually do the profiling, collect the data, and do some data science on it that you figure out, oh, that's the place where I do need to drop down to C. So you have to think about, how do you scale, but how do you scale at the right time? How do you avoid scaling too early? And so in the context of data science, this might be, when is it time to move to Hadoop? At what point do I have to drop out of, a simple local database or even a flat file and spend a bunch of time setting up my Hadoop cluster so that I can save time on the back end? And now finally, just monitor what's happening, right? I was just talking about this a couple minutes ago. You always have to think about whenever you've got numbers, whenever you've got data, you should be looking at that data and not just looking at it by eye, but looking at it in an automated way that, you get a notification every time something goes wrong. So, this isn't just for data scientists, and I don't think data scientists should even be a category, but it's thinking about, how is this idea of data science becoming democratized so that everybody is doing it? I've talked to people who work at companies like Etsy and Puppet, for example, and they're starting to learn R, right? Because they've got a lot of data and they need to deal with it. But they need to remember that, it's a different problem space, and yet there's so many things that apply across those spaces, right? So you can write an R, you can maintain that code in GitHub, you can, use monitoring when you're doing data science. It's not one or the other, and it's about, how can you mix those worlds together and gain something from it on both sides. And then, where do you get data science into this? Well, if you think about, what monitoring looks like today, it usually looks like a simple graph, right? You've got 20 different graphs with all kinds of crap on them. You're not really sure which ones are important or what's really happening. And so, you add data science into that, suddenly you can model the trends. You can fit a pattern to it, and you can know when anomalies are happening that are different from the pattern. And, if you've got 10,000 data points, it's a lot easier if you can describe those data points as a Gaussian distribution with two numbers in it, right? Then you know exactly what it looks like, but in a much simpler representation. Like we were just talking about abstracting away the complexity this morning. You know, if you learn statistics and work with data, then you can abstract away all the complexity of the numbers, right? Instead of 1 million or 10,000, you've got 2 or 5, depending on the kind of distribution you're dealing with. And every time you can describe something more simply, that makes it easier to talk to other people about it. So, you know, basically, this is what you get out of it, right? You do data science right, you do it like DevOps, you do it like, you know, good software engineering, or at least the kind of engineers who care about DevOps, and you make it easy to replicate, easy to build upon, and easy to scale. So hopefully this was interesting to you guys. I'd love to hear from you either way. If it was or wasn't, come talk to me afterwards. Thanks for your time.